First of all, the synchronizer is a framework. It's a proven framework, and it's comprised out of many different components that can be put together in many different ways. So the way that we communicate across the boundary between the mainframe and the remote system can be different, but essentially the way it works is fundamentally always going to be the same. This is regardless of the method of communication, the mainframe we are talking about, and the outboard system we are talking about. Here we have an existing application which is seen on the host application on the top left hand corner. It is written in COBOL, but it could be written in a different language. It's running perfectly happy on the mainframe, and it is in the process of being rewritten to work on the outboard system. The synchronizer imposes rules on that rewrite so that there will be equivalent functionality on both sides, and the basis of the synchronizer is that it checks that the functionality is the same. The host application, before it's compiled and deployed on the host system, is run through a preprocessor. The preprocessor is driven by a configuration file, and the configuration file tells it wherever you see, for example, a DMS store statement, I want you to call a certain piece of code which is going to trap the data, and it's going to save it off and then send it across. There is a library function that it will use, the find store library, and it will send it across through the send library directly or indirectly through the update journal. The update journal is another DMS2 table that keeps track of all the updates and is subject to all of the same recovery constraints as the main host program. So if a transaction aborts, then the update journal will be rolled back so that we don't get an out of sync condition because of a host program abort. The host object program executes all of the finds and stores, as well as sends and receives. Essentially anything else we choose can be trapped, intercepted, the data saved and sent across to the remote system. Over on the right hand side of the diagram, you see there is a mechanism for receiving the updates. We can use a messaging system such as MQ series, but we can also use simple socket communication, and the way that we have done this at one of our installations is actually to use a combination of socket communications as triggers, but to retrieve the data from the update journal directly using the Unisys DMSQL facility. That is a root access to DMS2 data using SQR statements that works fine. When an update is received, it is passed to the mapping service, and the mapping service is aware of the data format, and it's also aware of the mapping between the DMS2 data and the relational database data. Here we have Oracle database, but it could also be a DB2 or SQL Server and so on. But the point is that the relational data is likely to be in a complete different form to the DMS2 data. It won't just be an equivalent. There may be several different tables involved for one table on the mainframe. The data may be split up in other ways, but the mapping service's task is to take care of that and place each data element where it belongs, in the correct column, in the correct table, with the correct key. This is what we call data synchronization. If we go on to the next slide, we will talk a little bit more about functional synchronization. This slide, headed Parallel Running of Rewritten Transactions, is really focusing on the transaction integration. We've already discussed the data services integration on the lower half of the slide, and that is important where we don't have any rewritten transactions as yet on the Linux side. The constraints of the synchronizer are that there will be an equivalent function on the mainframe to the new transaction on the Linux side. The way that the transactions will work is when a transaction is initiated from Linux, as you see on the right hand side, there is the user interface which will be totally different from the original one, and there is an interface to the services. The services we are talking about are the transaction services. The interface will be something like a REST call and will pass all the information necessary to run the transaction on to the synchronizer. The transaction will be first run on the Unisys side. So, in other words, the synchronizer will send the transaction back up to the mainframe, and the mainframe will execute the transaction. Remember, this transaction must be functionally identical to the original host transaction. The result will be some data change, possibly new records or updated records. These will be captured by the logic that is inserted into the programs, and it will be captured and sent via whatever transmission mechanism we have implemented back to the synchronizer. This change will be encapsulated in a set of updates that the synchronizer can identify. The synchronizer can identify the end of that series of updates and then, assuming the transaction was successful of course, give the Linux transaction side permission to carry on. The transaction is then executed in the new application of the Linux side and control is passed back to the synchronizer. The synchronizer then has two sets of equivalent updates: the updates that were done on the host and the updates that were done on the Linux side. They are different, but there will be a mapping service to be able to establish equivalence. The final step is the synchronizer compares the state of the database for the set of records that were updated on the host with the state of the relational database on the new system, and then check that they are the same. If they are the same, we can say that the rewritten transaction succeeded, and we will flag that as such. If they are different, then we will report that as an error and flag the data involved as out of synchronization. The error has to be investigated by the programmers and the error corrected. The host program is deemed to be the master, but if there is an error, it's likely to be in the rewritten transaction, and the developers of the rewritten transaction will have a lot of information available to them to be able to find the cause of the problem. Not only can we show them all of the updates that took place on the host system so that they can determine what should have happened on the new system, but also we can capture the processing route through the host application and give them that information as well. The instrumentation of the host program can be not only to capture updates, but it can also capture the path of the logic through that application program, and that is something that can be saved and given to the developers as a debugging tool. Once the new transactions are reliable, then they can be phased in and control can be given to the Linux side for those transactions. Thus, the application can be phased in and proven at the same time. We thank you for taking the time to watch this presentation. For further information, please contact us through our website, mssint.com.